You know that feeling when you're on a website and it just doesn't feel alive? Like you're waiting for a message or maybe a sports score to update, and you just find yourself mashing that refresh button over and over again. Well, that lag, that annoying delay, that's the exact problem we're going to tear down today. So let's get right into it and see how WebSockets are the magic that makes the modern web feel, well, instant. Yeah, this quote just nails it, right? Imagine trying to work with someone on a dock and you're totally out of sync. That feeling is exactly where the old web technology just hit a brick wall. It made collaboration feel clunky and broken. And you know the crazy part is, it wasn't because of bad code or anything. The problem was way deeper. It was the very foundation the web was built on. Okay, so this is where we see a huge shift in thinking. For a long, long time, the web worked kind of like sending letters. Your browser sends a request, that's one letter. The server sends an answer back, that's another letter. And then silence. The conversation's over. You have to start all over again for the next piece of info. WebSockets completely threw that out the window. They created, instead, a continuous open phone call where either side can just chime in whenever they have something to say. So to really get why WebSockets are such a big deal, we gotta look at the problem they were built to solve. You see, traditional HTTP, the protocol that basically built the entire web as we knew it, was designed for one thing: fetching documents. It was never meant for a back-and-forth conversation. It was a one-way street, plain and simple. The client, your browser, always had to be the one to start talking. And the technical jargon for this is half duplex. The best way to think about it is like a walkie-talkie. You talk, then you have to say, over, and only then can the other person reply. The server could never just tap you on the shoulder and say, hey, here's an update. No way. You, the client, had to constantly pester it. Anything new? How about now? Got anything for me now? You can see how that gets super inefficient, especially for apps that need updates right now. So before WebSockets came along and saved the day, developers were smart, right? They came up with these clever hacks and workarounds to try and fake a real-time experience. But as you're about to see, these fixes, well, they brought a whole new set of headaches with them. All right, so the first and simplest idea was something called standard polling. It's pretty much what it sounds like. Your browser would just call up the server every, say, 5 seconds, nonstop. Got anything new? And the server would be like, nope. 5 seconds later, anything now? Still no. It was just so wasteful. Imagine all that network chatter, all that energy for a conversation that was mostly just, no, nothing new. A total resource hog. Okay, so polling was not a great look. The next evolution was called long polling. This was a bit more clever. The client makes a request, but the server doesn't answer right away. It just waits. It holds that connection open until it actually has something new to say. Then, boom, it sends the update. The client gets it and immediately opens another connection to wait again. It was definitely better, no more pointless nope messages, but it was still pretty clunky. Connections could time out, and it was still really heavy on the server. And this is where our story gets good. All those problems, all those clumsy workarounds, they paved the way for the real solution: WebSockets. Forget the one-way street, forget all the hacks. WebSockets came in and built a genuine two-way superhighway for data to just flow freely. So the magic word here is full duplex. Remember that walkie-talkie analogy for HTTP? Well, throw that out. A WebSocket is like a telephone call. Both you and the server have the phone to your ear, and you can both talk and listen at the exact same time. It's a single, persistent connection. And this means the server can send you data the instant it has it. No more asking. It just arrives. And the result of this is just a massive leap in efficiency. I mean, it's huge. You make one connection, just one, and it stays open for as long as you need it. This absolutely slashes latency. That's the delay you feel, because the system isn't wasting time constantly building up and tearing down new connections. You can have thousands of messages flying back and forth over that one single open channel. Okay, so you're probably wondering, how does this magic trick actually work, right? How does a plain old HTTP connection suddenly morph into this powerful two-way superhighway? Well, it all starts with a very clever little dance called the upgrading handshake. And the secret password to this whole operation is a number 101. Here's what happens. The client sends what looks like a normal HTTP request, but it tucks in a special header that says, hey, I'd like to upgrade to WebSocket. If the server is on board, it replies with this special status code 101. And that code literally means, you got it, let's switch protocols. It's basically a quick 4-step shuffle. Step 1, the client asks to upgrade. Step 2, the server checks the request, does a little security check we'll talk about in a sec. Step 3, the server shoots back that 101 switching protocols response. And step 4, poof! The very same pipeline that was just speaking HTTP is now a full-blown WebSocket connection. It's awesome. So, about that little security check, it's kind of like a secret handshake. The client sends the server a random, unique key. The server takes that key, mixes it with a secret GUID that only WebSocket servers know, does some crypto magic on it, and sends the result back. This is how the client knows for sure that it's talking to a real WebSocket server, not just some random web server that's going to get confused. And there's one last clever piece to this puzzle, and it's called masking. Every chunk of data the client sends to the server gets a little bit scrambled. Now, this sounds like it's for security, but it's not. It's actually for compatibility. It's to fool any old, grumpy network hardware in between that might see the traffic, think, hey, that looks like HTTP, I should cache it, and totally break the connection. Masking makes it look like gibberish to them, so they just let it pass through. Okay, so that's the how, the nitty-gritty of the handshake and the connection. But maybe the most important part is the when. When should you actually reach for WebSockets? Because they're super powerful, for sure, but they are not a silver bullet for every problem. So let's get practical. This is really the sweet spot. Think about chat apps or those collaborative editors like Google Docs where you can see people typing in real time, or stock tickers where every millisecond counts, live sports scores, and definitely multiplayer gaming. If you're building anything that needs instant, two-way communication, WebSockets are almost certainly your answer. But hey, knowing when not to use a tool is just as important. For example, if you just need updates flowing from the server to the client, like a live newsfeed, there's a simpler thing called server-sent events that's perfect for that. If your data only changes like once an hour, keeping a WebSocket open is total overkill. Just pull it. And if you're streaming big stuff like video or audio, there's specialized tools like WebRTC that are built for that. Really, it all boils down to one simple idea. Use the right tool for the job. WebSockets are an absolutely essential tool in any modern web developer's toolkit, for sure. But the key is to look at the problem you're solving and pick the protocol that fits it best. And I think this quote just wraps it all up perfectly. WebSockets really did turn the web from a slow, turn-based series of letters into a fluid, continuous conversation. They are the reason we have the incredible, responsive, live apps that we just kind of take for granted these days. So that leaves us with one final thing to think about. WebSockets absolutely crushed the big bottleneck of the last decade, right? They gave us that instant browser-to-server link. But our demand for real-time everything is only getting bigger. So as we push forward, what's the next big bottleneck going to be? What's the next great challenge we'll need to solve to make things even faster and more connected?